Okay, here we go. Factoring. More factoring. So factoring a matrix. So pause and copy all this down. What do I want to say? So sometimes this is called conditioning the matrix. So you're taking a matrix A and you are factoring it. You are kind of doing something to the matrix A in order to condition it so it works better for you. Okay, one thing that comes to mind is if you're doing like x is equal to b1, x is equal to b2, x is equal to b3, and you're solving all these systems, the a stays the same every time, but you have a different b. Okay, this factorization can help you there. Okay, it makes all the little row reductions a bit easier. You have to do some work beforehand, but overall it is more efficient. Okay, here's the algorithm. So pause and copy all this. Pause and copy. Pause and copy. First step is easy. Just reduce to echelon form. Just don't do anything weird. Just do the most basic row reduction that I taught you back in 1.2. That'll give you U. There's a sentence in here. This sentence here is quite the mouthful. Okay, maybe read that. Maybe pause and read that 3 or 4 times. If still, that's okay if it doesn't stick. I'm going to do some examples, of course. That's the hardest part. Okay, let's do an example. That'll be the easiest way to illuminate. Okay, so I'm going to very basically reduce this to echelon form. Don't do anything fancy. Only replacements and only use your current pivot to kill things below. So I'm going to leave that first row alone. And I'm going to do row 2 minus 3 row 1. And I'm going to do row 3 minus plus, rather, half row 1. I would generally avoid this, but in the LU section, it becomes feasible. Okay, what am I doing? Subtract 3 times. 3. Brain stopped. Oh, there it goes again. And then the brain keeps stopping. Subtract 3. 3, okay. How am I doing? Yep. Okay, now add a half. 0, of course. Add a half. Minus 6. Add a half. 10. Add a half. Minus 1. And then what? So here's my current pivot right here. Here's my current pivot row. So I'm going to add a multiple of that row to a row below. 0, 0, 0, 5. Okay. And there we have it. That is my matrix U. Okay, this is quite restrictive. Okay, we're only allowing ourselves to use these types of operations. Okay, you can extend this LU thing to more complicated matrices, but that's a whole nother can of worms that we will not get into in this course. Okay, for L, to find L. So I start with the identity of a certain size. What size? This is 3 by 4. So I is 3 by 3. Not I, L. L is 3 by 3. So as I said in the algorithm, you start with the identity matrix, just ones on the diagonal. Okay, above the diagonal, you're just going to leave the zeros. Now, I want to go through this sequence of operations. I want to go through it backwards. So I'm going to start with this guy. Now, what do I want to do? Or what do I want to end up with? I want to choose entries down here so that if I perform this sequence of operations on my L, I will end up with, the identity. So, and in the algorithm, I say go through this sequence backwards. So start with this guy, R3 plus 2 row 2. That means that this number here has to be not a plus 2, it's got to be the other sign, minus 2. Because now, if I take this operation and do it here, I will get a 0 there. Okay, next operation, this one. It's going to give me a minus half down in the bottom left. And then finally a plus 3 from this minus 3 here. Okay. Why don't you try one of these? Maybe if you haven't copied that, you can copy L there. So again, I went through this sequence backwards. Okay, starting here, gave me this minus 2. And then this one gave me the minus a half down in the bottom left, and then plus 3 came from that guy. Okay, try one of these. Exercise, exercise, exercise. Where are we? 2 minus 2, 5. Oops, 5. Okay, give that a try. Find L and find U. So pause and try that. Pause and try that. Pause and try that. Okay. Add 3, add 3, add 3. Subtract 4 times, subtract 4, 3, 4 times, subtract 4 times. And add. Oh, don't forget to label your row operations. Row 2 plus 3 row 1, row 3 minus 4, row 1. 2 minus 1, 2. Okay, so there's U there. Now for L, you start with the identity, which is 3 by 3 in this case. And then you go through this sequence backwards. Row 3 plus row 2. That's going to give me my minus 1 here. Then I get a plus 4 from this minus 4. And then I'm going to have a minus 3 from that plus 3. Okay, how are we doing? What time is it on this video? Okay, one more exercise. Pause and copy this if you haven't done so already. Let's try something non-square. Okay, pause, copy, and try this one out. Pause, copy, try, pause, copy, try. Okay. So row 2 minus row 1. So row 1. Where am I? Yeah, 1, 1, 0. Okay, that's what I got. That's what I got. And for L, this is 4 by 3. So L is 4 by 4. L is 4 by 4. You start with the identity, okay, where blank entries are zeros. Now, placing numbers below the diagonal by going backwards through here. Okay. Row 4 plus row 3 gives me a minus 1 here. Row 4 plus row 2 gives me a minus 1 here. Then I get a plus 2 there. Now row 3 plus row 1, that's a plus 1 there. And I get a +1 here. Let me just double check that. Looking at my notes, yeah, it looks good. But what about this entry? Ooh, what's going on there? Well, that is a 0. It remains a 0.